Okay, welcome back to this playlist series on installing a single node OpenShift home lab cluster. Hopefully by now you've got the hardware that you need and you've created your developers.redhat.com account. If not, go watch the previous video and get those things set up. And now what we're going to do is get that infrastructure configured and get set up to run the installation. Okay, so go ahead and go to my blog if you're not already there, upstreamwithoutapaddle.com. The post that you need to click into is this building a single node OpenShift home lab agent-based install. This is going to be the follow along instructions that you're going to do as we walk through this and build this thing out, okay? And the first thing we're going to do on your workstation is install some scripts, bash shell scripts that I've written that I use to manage my own home lab. The scripts do a lot more than what we're going to use them for today. They're highly opinionated to how I do my lab work, and unfortunately, they're very poorly documented because I use them for my home lab. I haven't taken the time to really document them because they're not honestly intended to be a product. They're something I'm sharing with the community, just because some people might find it useful. Okay, you can find those at this project in my GitHub account, Camaratos. This is where I maintain all the scripts that I use for my home lab. We're going to clone this and we're going to install this on your local workstation. All right. Now, a couple of caveats before we do that. As you can probably tell from my screen, I am working from a MacBook. Okay. I've crafted these so that I'm fairly certain these scripts will work out of the box on a RPM based Linux distribution. Like Fedora or CentOS Stream or even OpenSUSE or something like that. Okay, they'll likely work on any Linux distribution. I have a few friends that have also used these scripts, and so far as I know, they've mainly used them on CentOS or Fedora, or a RHEL build. Okay, so if you try it on Debian or Ubuntu or another Linux distro, you might have to do some tweaks to them. The other caveat I'll say is that I have not tried this at all on a Windows workstation. I have an assumption that if you install Windows Subsystem for Linux, this will probably work. You might have to do some twisting, tweaking, poking, prodding, install some utilities to make it work. But I haven't tried it there, and I apologize to those of you who are Windows users. I don't own or have access to a Windows workstation to do this work on, and it's out of the scope of what I'm doing. So apologies to those of you. I'm doing this on a MacBook. And the first thing we're going to do, if you'll follow along here, is we're going to create an opinionated folder structure starting from your home directory. We're going to clone my lab utility project, and we're going to copy the shell scripts from it into this opinionated directory structure. Okay, so let's go ahead and do that now. If you will copy those commands there, paste them into a shell terminal, and run them, you should now have a new opinionated folder structure. I'm using VS Code here to illustrate this for you, where all the shell scripts have now been installed under OpenShift lab bin. And there's this folder called lab config, where in just a little bit we're going to drop some configuration files. Okay, so let's continue working through this. We've got the scripts now. The next thing we need to do is add them to our running shell so that it has the environment and the functions, the shell functions necessary for managing the lab. Okay, so if you're using bash, you need to add it to your bash RC. If you're using Z shell, add it to your Z shell RC. Okay. The script that we're going to put in there, if you go to the bin folder, it's this labenv.sh. We're going to have this initialized as part of our shell so that these functions for managing the lab environment are there already at your fingertips. Okay? Take a look at this shell script and just make sure that you're comfortable with this being active in your shell anytime you start a new shell. If you're not, that's okay. You're not going to hurt my feelings. I promise this isn't doing any crypto mining for you, but you may not want to add, this opinionated structure to your running shell. If you don't want to do that, all you have to do is run this labenv.sh, source it, do a dot, and then the path to the env.sh and hit return so that it activates in the active shell that you're using. You'll have to do that if you're not comfortable just adding this to your shell. But take a look at it. I think you'll be okay with that. If you are, just do this to append it to your Z shell RC or your .bash RC. Okay, so you'll end up with something that looks like this. So you see at the very end of my Z shell RC, it's just doing this dot, it's sourcing this labenv file into my running shell. So if you're not going to put this, then you'll just have to manually run this particular command anytime you get ready to do any work with your lab. Okay, so now that that's done, what we need to do is start a new shell. We need to start a new shell so that it gets activated. And you'll see when I open a new tab here, and I do an env, you'll see now there's some new environment variables set. There's this OpenShift lab path, there's this lab config file, this lab config list, okay? So that's now active in my shell. The utilities are up, they're ready to go. The next thing you need to do is you need to install this YQ utility that Mike Farah has written. This is a fantastic utility. You can get to the link. I've provided it for you here in the blog post. This is a fantastic utility for manipulating YAML files and JSON files for that matter. It will even work with XML and other things. This is an excellent utility, and this guy has done a fantastic job building it out. So go install that. If you're on a MacBook like I am, you can do it with Homebrew. And if you don't have the Homebrew package manager installed, you should. It is an excellent way to manage packages on your MacBook. All right, so I'm going to run this. You'll see that it's already installed, so this didn't do anything, but since you're following along, I'm going to go ahead and do that. I've got 4.44.1 is the current version of YQ that's installed on my workstation. Okay, if you're using a Linux workstation, I've provided some shell commands here for you to go grab the latest version of YQ and install it on your Linux machine. Okay, now one more thing we need to do, you need an SSH key pair. Okay, so if you don't already have a private public key pair, then here's a command that you can use to generate one. Although you might not want to use an RSA one, there are newer algorithms that are considered more secure. I've provided the RSA one here because it pretty much works with everything, even though it is getting a little long in the teeth these days. But you need to generate one if you don't already have it. Once you have it generated, then we need to copy the public key into our OpenShift lab path folder. Okay, so by doing that, now when I come back over here and you see my OpenShift lab folder, there's my public key right there in the OpenShift lab. All right. So we've got our SSH key. That's important because we're actually going to use the SSH key both for logging into our GLINet router. We're not going to allow root password to log into the GLINet router. We're actually going to disable that when we configure the router. We're also going to use SSH authentication for you to actually log in as a core user to the underlying Red Hat Core OS of your OpenShift cluster. So if you wanted to, you can shell into the node and see what's going on and muck around with the Core OS operating system and create all kinds of chaos for your OpenShift cluster. Okay, so we've got our SSH key in place. The next thing we're going to do to get prepared here is set up some opinionated configuration files that my scripts are going to interpret in order to build your lab. All right. Now, you're going to need to go grab your Intel NUC and flip it over and get the MAC address off of the bottom of it. There's a sticker that's got the MAC address on it. Make sure you get the one for LAN, not Wi-Fi. We're not going to be using Wi-Fi on the Intel NUC. So get the one for LAN and write that down because we're going to need it here in just a minute. Okay. So first file we're going to create is an opinionated configuration file for the lab itself. My scripts are going to interpret this to configure the network on your router. In this case, 10.11.12.0 is going to be our network, and it's a Class C network, a /24. The router's IP address is going to be 10.11.12.1 when we configure it. This install host entry right here says that we're actually going to use the router to host the artifacts for the installation. I do have other configurations in my lab where I use a Bastion host like a Raspberry Pi or a little Linux box of some sort where I host all of the files. I mainly did that back in the days when I was using the lower powered AR750s from GLINet because they frankly didn't have enough juice to serve all of that and be a router. This AXT 1800, no problem. So unless you want to do a disconnected lab, this install host right here will be the router. Ignore this CentOS mirror entry. We're not going to be installing CentOS Stream because we're not going to be doing any KVM hosts. So that one right there is just there because my scripts expect it to be there, but it's not used for anything. Same thing with this empty array of the subdomain configs. That's so that I can configure multiple networks below the edge network. I do run my lab sometimes with like multiple regions or multiple data centers where I have a router for each of the regions or each of the data centers, and those routers are then all tied up to an edge router that is my internet gateway. That's what this subdomain configs is for. We're not going to get that complicated in this. We're just doing one single node OpenShift cluster that's going to be right on our edge internet gateway. And that's what this next section defines. It defines the cluster configurations and the domains, if we had subdomains, that they belong to. And in this case, one cluster on the edge domain, so we're keeping it nice and simple. With that said, let's go ahead and create this lab list.yaml file. We're not actually going to be doing anything with this one today. It's just something that my scripts expect to be in place. I use this because I have a slight addiction to these Intel NUCs, so I have a number of them. And I actually maintain multiple lab configurations. This is just a handy utility so I can toggle between my various lab setups to leverage them. And that's what this next command, we're going to create a symbolic link between this lab list YAML and a lab.yaml file. That symbolic link, we're just bypassing something that one of my scripts would do to select which lab is going to be the lab that we're managing for that given session. So by doing the symbolic link, we're just skipping that. Okay. This next one, this is where we need the MAC address off of your NUC. So we're going to create the opinionated cluster configuration file now for the cluster that you're going to build. And while you go get your MAC address, I'm going to pivot over here and I'm going to open this file. So in your OpenShift lab directory, go into lab config, find the folder called cluster configs. In there, you'll see a sno-ocp-4.15.yaml file. It's the one we just created. This is the one that my scripts are going to consume in order to leverage the OpenShift install utilities to create the artifacts to install the OpenShift cluster. It's also going to configure DNS in your router. It's going to configure the Pixie Boot installation, and it's going to create all of the Pixie Boot artifacts for the server to boot from. Okay, and that's why the MAC address is important. So get the MAC address for your router. I'm going to copy the one that I saved previously for mine, not your router, I'm sorry, your Intel NUC. And I'm going to paste it in there. Okay, so put your MAC address right there like that. Save this file. Now, I'm going to come back over here real quick. And I'm going to walk you through what this file is that we just created. Okay, first thing is the name that we're going to tell the OpenShift installer to give your cluster. So this cluster is going to be named SNO-OCP-415. Next two lines are determining the networking of the cluster itself, the cluster's CIDR and the service CIDR for that network. You'll notice they're a /14 and a /16, and they're using private IP ranges. Next two lines here, the remote registry, the tools URI, this is telling my scripts where to go to get the OpenShift installation artifacts and the tools to create the installation itself. This set of lines here called butane. Butane is a command line interface that is really handy for creating CoreOS ignition files as well as OpenShift machine configuration files. And my scripts actually use butane as part of the creation of the installation artifacts to customize the installation before the install starts. Same thing is true for this nm state cuddle. This is another command line interface that the installation is going to use to configure the networking for the underlying Red Hat CoreOS that's going to get installed on our Intel NUC that will host the OpenShift cluster. Here we're telling it that this is not going to be a desk-connected installation. My lab is set up so that you can actually do the install with a mirror of the OpenShift images hosted on your own Artifactory or Sonatype Nexus or Quay.io hosted registry of some kind, so that you could do this without connection to the internet. That's obviously something that a lot of large enterprises do in production. The last couple of lines are just telling it this is an OCP release, not an OKD install. That tells my scripts to do things. And we're telling it that we're going to install the release 4.15.11. Okay, so that was a lot to walk through. The next bit is defining the control plane. Literally, what's going to be on this little guy here. And what we're saying is that the boot device, where CoreOS gets installed, is going to be dev SDA. It's that little 40-ish millimeter M2 drive that you put in there, the 128 or the 256 gigabyte one. The next line is telling it which device to use for the host path provisioner, and that's going to be the NVMe drive that we installed. And then the last thing, we're defining the network configuration of the node itself. If this was a high availability install with 3 control plane nodes, there would be 3 entries in this list. This is a single node OpenShift cluster, so there's 1 entry. The IP address that this node is going to get on our lab network is going to be 10.11.12.100. And the MAC address is going to be used to identify this host on the network. The Pixie files that it's going to boot from are going to be named with this MAC address in their name so that it pulls the right files. The reason I do that is in my larger, more complex lab setups, this allows me to specify the configuration, the personality, if you will, that every node gets when it's installed. So I don't have to build a base image and then go back and modify it after the fact. I can create the ignition configuration up front that gives the machine the specific personality that it's going to have within an OpenShift cluster or separate from an OpenShift cluster if it's going to be a CentOS stream box. Okay, so that's one of the reasons that I use the MAC address here. All right, so we've got our MAC address in place. We've got all of our files created. The next thing that we need to do before we start setting all of this up is you need to use your developers.redhat.com account that you created. Go to this link, console.redhat.com, OpenShift downloads, okay? You can just click the link from my blog post. Log in with your developers.com account. And in this drop down you see here for the downloads, select tokens. And you'll see two items in this list. What we want is the pull secret, okay? Copy that pull secret into your buffer. Come back over here, and what you're going to do now is you're going to create a new file under your OpenShift lab path. So under your /home whatever OpenShift lab, under lab config. So go to lab config and create a new file, and you're going to name that new file OCP-pull-secret. Okay, so create a new file named OCP-pull-secret. Right, under lab config, right there. And in that file, paste your pull secret, okay? Now, while I do that, I'm going to turn off the screen share for a minute because the pull secret is exactly that. It's a secret. Treat it like a password. This thing is unique to you and you don't want to share it, okay? So put that pull secret into that file, OCP pull secret, and we are now set up to start the next phase of this configuration. Okay, so I'm going to stop this video here, and I'm going to get the hardware plugged in and ready to go. Go ahead and get your Intel NUC, get it plugged in. Don't turn it on yet. Get your router, and you can go ahead and plug your router in. It will come up with a default configuration, and we'll connect to it here in just a minute. First thing you're going to want to do when you plug in your Intel NUC, actually, I'm going to resend one of the things I just told you because you are going to want to boot it up, or at least power it on. It's not going to have an operating system, but plug in a monitor and a keyboard. Go ahead and power it on, and in the BIOS, you need to disable secure boot, okay? Because we're going to be using Pixie Boot, and the init kernel and the initial RAM disk and things like that, they're not going to be, air quotes, trusted artifacts for it to boot from. So turn off secure boot in this little guy in the BIOS. The other thing to do is set it up for Pixie Boot. Set the option so that it has unlimited network boot options, and make network boot the last in the boot priority, so that it will always network boot if it can't find something else to boot from. But once it has an operating system on that internal drive, we don't want it to Pixie boot anymore. Okay, so go make those changes to the BIOS and get it set up and ready to go. Also, go ahead, go to Intel, download the latest BIOS and flash to the latest, because this is a good time to upgrade it. Once you have this thing built, you're not going to need a monitor and keyboard on it anymore. It's going to be headless. All right, here's what my little setup sitting out here ready for us to start install looks like. The only reason I have a monitor on it right now is just to give you something to look at when it pixie boots so that you'll be able to see what's going on over there, and we can keep an eye on it while it gets through the first stage of the installation. Okay, so go do those things. Get your machine set up. Get your router plugged in, use a network jack to plug this thing into one of the LAN ports, and come back to the next video and we'll configure your router and get ready to do the OpenShift installation. Okay, I'll see you back here in just a bit.